Just a quick correction to this video. You're going to see me do a bunch of mathematics, but I missed something that we learned in like fourth grade. The area of a triangle isn't just base times height; it's 1/2 times base times height. So this should be, 1/2 times 10. You're going to see me make a correction at the end of the video. That should be a 5 at the end. This problem wants us to calculate the rate that the height of the water is changing. So if h is our height, we want h prime. So we want to construct some sort of equation that can help us relate all this information we're given to the rate of change of the height. And I think the equation we're going to want is the volume equation. The volume of this thing is, the volume is always just like we do with anything else. It's like base times height. If we can find the area for this base here, the area for this base as it's changing, and we multiply it by the height, it'll tell us the volume of the water that's currently in there. So it's isosceles. I'm sure we'll use that somehow. The base of the triangle. That's also constantly changing. So we'll call that lowercase b, right? Because the base is longer here, it's getting even longer up here. So it's base times the height of the triangle, which is also changing depending on how much water is in there. And then it's multiplied by the height of the entire three-dimensional figure, so multiplied by 10. And this 10 is a constant. It's always 10, no matter where we are in terms of the water in here. So that's the volume. It's the area of the triangle times 10 to stretch it out throughout that entire, what do they call it? Trough. Okay, so that's the volume. If we want to start talking about h prime, then we want to take a derivative of the volume with respect to time, because the volume changes depending on what part of, some sort of time interval we're on. And so we need implicit differentiation. The derivative of volume with respect to t, with respect to time, is something we don't know, so we call it v prime. And then the derivative of b with respect to time, the base with respect to time, is constantly changing. So we'll call that b prime times h, because I'm using the product rule here. And it's times 10, so I'll keep the 10 on the outside. So we got b prime times h plus b times h prime. Because of the product rule. Derivative of the first times the second kept the same. Plus the first kept the same times the derivative of the second. Okay, so now we have something to solve for. We have h prime we can eventually try to find. We just need to use the given information. We also need to know something about b prime. In the case of this particular instance, I don't think we can calculate yet either. So we need to know what the base is. We need to know what b prime is. We have v prime. We need b prime and b. And the way we're going to find that is by thinking about similar triangles. We've got this big triangle. If the thing was all the way filled up, we have a smaller triangle to represent the triangle for when the volume is partially full. So we can relate those two triangles to each other. And again, I think it's similar triangles is like the way that these problems are described in geometry. That this part all the way across, the big triangle, we divide that by our smaller base in this smaller triangle, that ratio should be equal to the height of the bigger triangle, which is 7, divided by the height of the smaller triangle, which is h. Okay, and the reason we can do that is because they're similar triangles, right? This triangle has the same ratio of two different sides as this triangle does. The bigger triangle divided by the smaller triangle's corresponding side. The bigger triangle divided by the smaller triangle's corresponding side, which we are keeping as a variable. And now if we take a derivative of this with respect to time, we'll be able to have an expression for b prime like we wanted. So what I'm going to do is I'm going to rearrange by multiplying both sides by h and both sides by b. And now if I take a derivative of our similar triangle equation with respect to time, we got 3 times h prime equals 7 times b prime. And then if we solve for b prime, we'll have that b prime equals 3h prime over 7. Now, we don't know exactly what b prime is. It still depends on h prime, but that's okay because the variable we're trying to solve for in the volume equation is h prime in the first place. So this will be great to plug in. Okay, so we've got this now. We have something to plug in for b prime. We have a particular height. We need to know what the base is at this particular moment. And again, we can use the similar triangle formula that we made. If the height of the water is at 3 meters, that means h equals 3, we can plug that in, and we should be able to solve for the base of the triangle, the b that I drew there. So we can multiply 3 to both sides, multiply b to both sides, and divide 7 from both sides. B is going to be 9 over 7. So we can plug that in our volume equation, plug in the fact that the volume is changing at 3 meters per second, so that means V equals 3, positive 3. And I think we got everything we need to solve. So 3 goes in for the volume. B prime is 3h prime over 7. H, the particular height at this instance, is 3 meters. The base we solved is 9/7. And then h prime is the thing we're trying to solve for in the first place. So we've just got some algebra to do. And then we've solved for h prime. So I'm going to divide 10 from both sides to start off. And then that's times 3, so I'll make that 9h prime over 7 plus 9 over 7h prime. So that's the same thing added to itself. I wonder if that's a coincidence or if that always happens with similar triangles. So they have common denominators, so that's 18h prime over 7. And so I want to multiply 7 over 18 to both sides. So that's 21 over 180 equals h prime. And then we can simplify that fraction. I think I did that right. So the height is increasing at 7/60ths of a meter per second, or per minute, I should say. This should actually be 7 over 30, and I'll show you why. It's because when I wrote this volume equation, the area of the base isn't just base times height. It's not a rectangle. It's 1/2 times base times height. So, yeah, it's a little embarrassing. It should be a 5, right? Because 1/2 times 10 makes 5 here. So if that's a 5, this should be a 5. We're dividing 5 from both sides. This should be a 5. So 18 times 5 makes 90 in the bottom here. And then when you simplify 21 over 90, that's 7 over 30.